Welcome to Clark Classroom. Don't forget to subscribe. This is an introduction to vectors. A vector has two important features. One, its magnitude, represented by its length, sometimes referred to as its modulus. Two, an angle, which gives it its direction, sometimes referred to as its argument. Because of these two features, vectors are very suited for real-world applications involving velocity, acceleration, and forces. A vector from point O to point A may be named lowercase a for ease of reference. The notation would be OA with an arrow on top, as indicated here. Similarly, a vector from point O to point B will be named OB with an arrow on top, but for ease of reference, we would name that vector B. Please note that the arrow is not an indication of continuity, as is the case in some geometric features. The arrow simply indicates the direction of the vector. Two vectors are equal if they have the same length and same direction. Vectors oriented in opposite directions are negative of each other. If two vectors have the same direction but different lengths, one is a scalar multiple of the other. So we have A and lambda A, where lambda is a scalar quantity. Lambda could be equal to 2, 0.5, 3, etc. There are two systems in which we perform operations on vectors. These are free-floating vectors and position vectors. In the free-floating system, vectors can be translated to anywhere in the plane. However, its length and direction must be retained. To subtract two vectors, we align them with a common origin, as illustrated here. Here, these two vectors, OA and OB, that's vectors A and B, are aligned so that they have the common origin. When they are aligned with a common origin, then the vector from A to B, that's from A to B, will be equal to the vectors B minus A. And of course, if you reverse and have the direction and have the vector from B to A, then that would be A minus B. To add two vectors, we orient them head to tail. In the free-floating system, you move B and position it so that it is now head to tail aligned in the free-floating system. All we have to do is make sure we maintain its direction and its length. And now the vector from where you begin, the beginning of A to where you end, is the vector A plus B. This is sometimes called the resultant vector. Please note here that the angle theta between these two vectors is designated as the angle between those two vectors. However, if you look in the orientation of the vectors head to tail, then this angle between the two vectors would be the angle on the outside here, or external. The one on the inside is the supplement. So this is important for you to know, as if you're beginning to solve problems, you need to know how to position the angle between two vectors. Position vectors, on the other hand, are expressed in the coordinate plane, all with a common origin at the origin. So let's look at an example. So the vector that ends at the point 2, 1 would be expressed as 2i plus j. Well, I is the unit vector that is in the direction of x, and j is the unit vector in the direction of y. To add or subtract vectors in the coordinate plane, we simply perform the operation on coordinates. So for example, if we are adding 2i plus j and 3i minus 2j, we simply add the coefficients of I and the coefficients of j. So 2 plus 3 will give me 5i, and 1 subtract 2 will give me negative 1. So that's negative j. And my answer would be 5i minus j. As we perform the operations on vectors, we will focus in the next video on how we actually do problems in both systems. If you find this video useful, please subscribe to this channel, and I welcome your comments and or suggestions.